here? Just like.
All the, there you go. Good morning, ladies. I think you're out of the old ones, so you can take them the new ones. I think you'll figure it out. Look through it, I think you'll see what you need there. So this one's done.
These like where's the liquid? You put the liquid in stuff here.
Go in the gray bucket here.
That you put in here. This one like that.
Yeah, that's it. Okay, I got some folks at home. Super. Okay, Isaiah, that's fine. Okay, today is the 1st of June. Crazy. And I've got Liam, Isaiah, and Zach. So good morning to all of you online. Isaiah, you don't have to be here because it's 9F, but you can if you wish. Alessia, good morning. You know what that is?
It's not green or yellow. It's
Silica gel. It's used to absorb water.
not valid or invalid. It's just not.
I don't know why they have yellow and green. Anyway, when it absorbs a lot of water, apparently it's then green, and then it's telling you there's too much water that's got into the kit. I don't know why the yellow color. None of them look yellow. They all look clear to me when I see them.
Yeah, normally there's yellow, but
Really?
yeah, like some of them. Oh yeah, here you can see it.
There's a little bit. Okay, let's go. Okay. All right. Okay, so after our corona test with the folks that are here, we're going to do solving parallel and combination circuits. For everybody that's here today, you'll turn your locks into your English teacher today. So your locks with your locker, they'll have a little piece of paper for you to put the combination and stuff on in English class today. Okay, and I've got Clara. Good morning, Clara. Good morning. Thanks, online folks, for being here. We'll start up once I get our corona test done here in school. Yeah. Okay, I'll take these again. Okay, once you get your negative, show me, and then I can check you off here in our official checkoff sheet. There it is. Yeah.
I don't think my test is one.
Why not? Then you need to get another one. Throw it in the gray bucket. Go ahead and find your stuff in the new kit there. Okay, let's review while we're all hanging around waiting. Folks at home can check this out too. So when last we met, we started out, and I drew this. I'm going to draw more, but what is this symbol? What is this symbol from last week, 2 weeks ago, whenever we did it? Folks at home too, if you can see that, what is this symbol right there? Let's see if you can see it. I'll get you as close as I can here. Not easy in this classroom. See if you can see it. Charlotte. Power source, good, yeah. Power source or battery. Okay. What about this symbol? This symbol, Lauren? Resistor, right. Let's see if folks at home can see that. Yeah, Zach saw the power source, as did Alessia and Clara. Good, so you guys can see. So I got a resistor, and I'll just put a couple more. Okay. You got it. Claire knew that too. Alessia, good. Thank you very much. All right, so my question here is, no matter where I put my marker down here, what's the same? What's the same everywhere in this sort of circuit? What's the same, Michael?
The flow of current.
The flow of current. So current's the same everywhere. Why is that, in your own words? Why is that the current's the same everywhere? Carol?
There is one whole circuit and many parallel, how do you say, connections that with the current.
Yeah, we're going to look for another word. I know you know it. I'm going to give you another word in a sec, or Malta will.
And there's only one way to that one.
Yeah, there's only one way, and let's see if somebody at home had the word. For resistors, right? Yeah, there's one pathway, is how we say it in physics. So one pathway for the electron. Okay, and I've got Tim over, Tim H. So thank you, Tim, for checking in. Let's see if anybody else is new. Thanks everybody else for participating. Looking good. All right, what sort of circuit is this? What sort of circuit? We had this last week. This is a circuit. Maybe somebody at home can help me. What kind of circuit is that, folks at home? I think you had that, all of you, with me when you were here together with me last week. Good, three folks now here. I know there's a time lag. I'm trying to give them a little time. All right, Charlotte? Combo, no? Series circuit, thanks, Lauren, right. And from home, Zach knew that as well. Thank you, Zach, good. Okay, what's a typical household voltage here in Germany? What could I write up here if it was a circuit in a German household, Linus? Yeah, 220 volts, thank you. That would be very typical. I'll put some numbers for the resistors. Let's say 10 ohms, 8 ohms, 6 ohms, 12 ohms. Okay, and I've got Corey there as well. Corey's checked in very well. Okay, so some questions here. This is review. How do I get the total resistance? What do I do with this sort of circuit? What we do today will be different, but what do I do? Maybe folks at home know as well. Type in a little answer. I know everybody's busy writing too. I haven't heard from Amelie. Amelie, you remember what do we do to get the total resistance for this thing? Add them together. Add the resistance of each resistor together. Let's see if somebody at home had that as well. Alessia had that as well. Add the resistors together. Right. So I'm going to say it in symbols first. Let's make this 1, 2, 3, 4. So I'm going to say the total is R1 plus R2 plus R3 plus R4. Because in physics, we like to have like equations too. So there's our equation. Good. Throw in the numbers.
10 ohms plus 8 ohms plus 6 ohms, 12 ohms,
Okay, do you have a total already for me, Kiara?
36 ohms.
36 ohms. Let's see if that checks with folks at home. Anybody got a total for me? Exactly. Add R12131, right, Tim? Good. And Liam has a 2. Add the resistance together. Okay. I think that's right. Looks good to me. Okay, then part B, how do I get the current? Well, I should ask you that. I is current in physics. So think back on a famous equation to help you get the current. So what did we use last week? Folks that were here, I want to get the current. Help me with a famous equation that you all knew from a nursery rhyme. Charlotte. Super. So twinkle, twinkle, little star, V is equal to II, and Charlotte has already solved it for I. So I is equal to V over R. Charlie, you want to throw in the numbers for me too? What would it be then? This would be the total current, so we need the total for down here.
220 over 36.
36 ohms, right? Yeah, need labels on all of them. Okay, Folks, can you divide that? You can use your phone for a calculator if you don't have anything else. So let's go ahead and get that. 220 volts divided by 36 ohms. I'll see if anybody else here had an answer. I'll try and get out of the way. Hopefully folks at home can see this too. Yeah, get it from the triangle, says Alessia, that's right. Okay, how about Timothy P, what you got? 6.1, what would the label be, Tim? For current? Amps, right. We can use a capital A for that, so 6.1 amps, look at that. Tim had the same thing, thank you, Tim, good. All right. That's more or less most of what we learned last week from about a series circuit. So today we're going to do a parallel circuit. Let me pause here and see if I've got any negatives. Any negatives you got to show me? If so, come on up and show me and throw your stuff away. And I'll check you off. Negatives. I've got a negative from Charlotte. Good. And from Kiara. Sorry, I'm looking at the wrong part of the alphabet here. Used to last week. Thank you, Amelie. And thank you, Malta. Thank you, Linus. Thank you, Timothy. Thanks, Michael. And thanks, Lauren. Okay. And Charlotte, did you show me yours? You did, right? I just put you in the wrong spot. Okay, now I got you in the right spot. Thanks, everybody, for doing that. Good. Okay. Yeah. Yeah. Thanks, Liam. And that's the right label, amps, as well, Liam. Okay. So let's do something new. Or getting warm. It'll be a warm day. So there we go. Take that down later. Okay, so I'm going to raise this because I want to have this as close to the right as possible for folks at home to see. So today what we're doing, we're solving parallel circuits. Okay, how about Linus? Draw me a parallel circuit in the air. How, Linus, did those look? Yeah, good. Okay, so he's drawn a box with some lines going through it, some parallel lines. So here's our power source again. And I'll draw what I think you drew. I'll put in also, Linus, some resistors. Okay. Let's make this one American household, so I'll say 120 volts. And let's label these 1, 2, 3. And I'll just pick some numbers out of my hat. So let's say 8 ohms, 10 ohms, 12 ohms. Just a reminder from last week, see you folks here, got that? No, Alessia. What do these little resistors do? Why do we have to use resistors? Why are they in your calculators and your phones and your laptops? What do resistors do? They arrange the amount of what that's going to get through. What do resistors change, so to speak, Michael?
The current,
The current. So if I wanted a lot of current to get through, what kind of resistor, Michael, would I use?
a low ohm resistor.
Super, right. Like, that would be maybe for a toaster, right? Because I want a lot of current to toast my toast. So I'd have a low ohm resistor there. A light bulb, we want very little amps to go through it. I'd need what sort of resistor in the light bulb? I want very little amps to go through my light bulb or else it burns out. Malta? You got it. So high amount of ohms resistor. Good. Let's see if folks at home remember that too. Yeah, Zach, I'm not sure what you're referring to, but then I don't remember everything I said. Okay. Let's answer some questions with this sort of circuit. Okay. So the first question is going to be, guess what? What's the total resistance? Okay, for the other circuit, the series, you guys told me to do what? Well, Amelie told me what to do. What do you do again with the series circuit with the resistors? I got to do what, Linus? Add them together. With a parallel circuit, it's totally different. And I'm going to give you the equation for it now. A lot of times in physics, I'll help to derive or show you where the equation came from. This one comes from a math called calculus, which you haven't had yet. So this is one of the few equations where I'm just going to say, gang, this is it. All right? So here's what you do. You can get 1 over the total resistance if I add 1 over R1 plus 1 over R2 plus 1 over R3 plus whatever. Here I got 3 of them, so I'm going to stop there. Kind of weird looking, isn't it? And that's another reason I have you write the equation once in physics, because sometimes the equations look very different. Okay, so let's see if somebody's following. So I'm going to go 1 over RT equals 1 over, okay, so how do I substitute these suckers in? Charlotte?
1 over 18.
Good. Can you keep going?
1 over 10. And 1 over.
Now, in the internet, they'll have you find a common denominator or some nonsense like that. We're not going to do that. That's crap. And I'll tell you why. A lot of resistors aren't nice even numbers. So here's the way I want you to do it that always works. Okay? So, and this is the smarter way I saw one of the professors on the internet doing anyway. 1 over t. Change them to a decimal. So 1 divided by 8, I need like a decimal, point whatever. If you know it, fine. If you don't, punch it on your calculator. So 1/8 is point what, and how about Linus, when you get there, let me know what you get. And while you're punching out, Tim, no, you can't just add them, 1 over 20 ohms. No, you got to change them to decimals. We'll show you how to do that now. Yeah, to regulate the amount of current. That's how we use resistors, right, Alessia? Exactly. Okay, Linus, what'd you get? Point? 125, exactly. This one we can do in our heads, folks. What's 1 over 10? 1 over 10 is what decimal, Timothy? 0 point. I'm gonna leave off ohms till the very end, okay? 1 over 12, I don't know. What is that one? 1 divided by 12. How about Malta when you get there? What do you get?
0.083.
Thank you. So, folks at home, change them all to decimals. Use your phone or use a calculator on your computer. And still, this side is still 1 over RT. I know it's ugly, but we're going to fix it. Don't get all worried. Let's add these together. So, 0.1 and 0.125 would be what? 0.225 plus 0.083. You guys are going to have to do that. I can't do that quick enough in my head. 0 point something. Who's got it? Kiara's got it? 308. Like that?
And then period.
No, not period. It's point there, so there's no period.
Repeating. I think you need repeating.
Repeating. No, we don't use that in science. So 0.308, and if it's 3 after that, that's enough left off. Okay. All right, so now, folks at home, are we okay? Yeah, Tim got the same thing. Thanks, Tim. All right, so you can do two different things. We agreed in math class I can put anything over 1, right? It doesn't change the number. Something divided by 1, right? You've done that before in math class. Okay. Now you could cross multiply, but I don't want you to do that. I'm going to give you an easier tool. The tool is to flip them both upside down. And it's called the reciprocal in math class, reciprocal. And here's the button on your calculator. It looks like this, x to the minus 1. Or on some calculators, it's 1 over x. That's the reciprocal button. Okay? You find that and do that. And what it does is it flips both fractions upside down. I can't do that when I got like 4 fractions. I can do it when I got a fraction equals a fraction every time. It's a great math tool. So then I got RT over 1, which is just RT. And now somebody's got to do that for me. 0.308 divided by 1. And it's going to be point something or other. I don't know what. 0 point something. See, folks at home, try it too. Let's see if we get the same thing. Ah, Julius is there. A little late, Julius. All right, Malta, what'd you get?
1 divided by 0.308.
No. 0.308 divided by 1.
That's just the same.
Or did I screw it up? Sorry. Sorry. I meant to write it. Pardon me. So thanks, Malta. I didn't leave you there very well. So it's 1 over 0.308, and then we've got to divide that, Malta. So flip it. So 1 divided by 0.308 is what? Is it 3 something?
3.25.
Good. Let's call it 3.3. And finally, folks, what label's on that sucker after all this work? 3.3 what? And it's not watts. 3.3 what at the end of the day? Yeah. Amps, no? Ohms, yeah. It's an amount of resistance. Folks at home get the same thing? Hope so. So 1 divided by, my writing's so sloppy. So we flip both sides. So I got 1 divided by 0.308, and that's 3.3 from Malta. Okay, now notice something. 3.3 ohms. Look at what we started with. 8, 10, 12. That is so weird. It's less than any of the 3. Let's see why that is. Let's see why that is. If it's less than all 3, you've done it probably correctly. Okay, this will be a little hard for folks at home, But imagine you're in actually, let's do it this way. You're in Berlin. You're in somebody's car. There's a traffic jam. You're downtown in Berlin. Okay, so I could just try and go right one way, but it's kind of full. So what else could I try? Another what, Emily? Another side street, right? So I could do this way. Or instead of going this way, I could go that way, right? In fact, the more possible routes, the less there is. The less, no?
And no, that's different.
Think about it this way. I want to use any physics labels, okay? What's going to be easier if I got a traffic jam? One route or 3 or 4 routes? What's going to be easier? Emily? 3 or 4. Will there be as much resistance with 3 or 4? No. So, interestingly enough, exactly, Alessia said the same thing, right? Less resistance. So, the more routes, or we say in physics pathways, the less resistance because there's more different ways they can go. Let's follow that and review, okay? So, here's your electrons, right? Coming from the negative. What do they do, Michael? What do they do when they get to this junction right here? Here come the electrons. What do they do here?
It's split off.
They split off. So some can go your direction and some can go down. And what about here?
They split off again.
Good. Now we're going to bring them on the way back. What happens, Linus, over here? Yeah, okay, they join and go up. And over here? Okay. And in between times, I've got 3 different pathways, right? So we can say to ourselves, aha, the more pathways, the resistance. The more pathways, the resistance. Folks at home can type something in too. Yeah, I think they can see that. The more pathways, the resistance. Okay. Charlotte, can you fill in the word? The less the resistance. Folks at home got that too? Yeah, less you had that, less resistance, right? Yeah. Makes sense, right? More pathways, I got more ways to go, less resistance. Because as Michael pointed out, the current splits, in this case, into 3 different pathways. So there's lots of different ways to go. Now, that's both a good thing and a bad thing. Here's why. Your apartments and homes, I think we said it last week, your apartments and homes, why are they not in a series circuit? Why would that be a bad thing? Why aren't your homes and apartments arranged in a series circuit? What would be the problem there, Malta?
Well, I think it's not everything the same amount.
True, that's one reason. Not everything's the same amount of current. That would be the same in a series. What's another reason? Folks at home, why aren't your homes or apartments built in a series circuit? What's the problem? So Malta says it'd be the same amount of current everywhere, and you can't have that. He's right, but there's another reason too. Michael?
The electricity wouldn't be able to come out of the pathway, it would have to stay in the circuit. You couldn't get electricity out of the walls or anything.
Okay, I couldn't get electricity out of the walls too. Oh, I got another latester. You'll want to watch the video, Evan, because you missed about half the class. Give me another reason. Kiara?
Well, because it would turn one thing on and then everything.
Okay, if I turn one thing on with Sirius, everything's turned on. I think Zach's gonna say the same thing. Yeah, all the appliances would be plugged into the same outlet, or Zach, yeah, so to speak. Or if I turn one on, they all go on. So that's not so good. Okay, with parallel, it is nice because I can turn each one on. If I turn that off, it's still, I got two pathways, right? If I turn that off, I still got two pathways. So your homes are wired in parallel. Homes wired in parallel. Parallel circuits. It's mostly a good thing, mostly good, so I can turn things on and off, but there is one problem with it, and it has to do with this low resistance. The more things I put in, ironically, we said, more things I put in, what happens to the amount of resistance? The more stuff I have going. What happens to your resistance? Timothy? The resistance drops. So the more stuff I have going, the more what increases. The more stuff I have going, the more what increases, Michael?
Current.
The current. Now that's not bad until you get too much. If I get too much, we said already, what can happen to the wires? They start to get what? They start to get warm, okay? So if I have too many things going at home, your wires overheat, they get warm, and you have an automatic, what's called a circuit breaker, or in German, Sicherung. And what does that do if you have too much current going? Can you guess, Linus?
Shuts off.
Exactly, shuts off the current, doesn't it? Either for one room or several rooms, depending how it's wired. Okay, so it'll go like this, and then what you should do is, before you turn it back on, you should do what in that room? Turn, Malta, unplug a couple things, okay? So you may not want to have the stove, the blender, the hair dryer, the dishwasher, and the electric mixer all going at the same time. You know what I'm saying? So that's a lot of current. So you may want to turn a couple things off, and then you can turn the circuit breaker back, or stick it on, and that will then take care of it. In the old days, they used a fuse, which actually burnt through. You ever heard the expression blew a fuse? They don't actually blow up, but in the old days when people used them, and there's still a few apartments in Berlin that use fuses, but not many. Not many. And there was a little tiny wire, and it would burn through if there was too much that would go through it. Too much current. Thanks, Mike. Exactly right. Good. Let's see. Okay, good. All right. Let's have you guys try one of these. A parallel circuit, I mean. Oh, we're not done. We got one more question. A. Oh, we've only done A. Well, we haven't done much at all. Okay, we got to go further. I hope these folks can see this. If I do it here, yeah, you can still see. So B, what's the total current? What's the total current? I need an equation. I think Charlotte gave it to me earlier, so let's get somebody else here. What equation could I use to get the total current, Linus? Yeah. How about in letters first? In letters first. To get the total, I got to divide what by what? Good man. Okay, so V over R, and we're going to say RT. And now I'm ready for you, Linus. Go ahead and plug in those numbers now. 120 what? Thank you. Over. Ohms, right? Ohms, yeah. Good. Let's do that. It's going to be what, around 30 or 40? You guys can let me know. Folks at home too can do that. You got it? Yep, Alessia had the equation as well. Thank you, Alessia. Let's put in the numbers and try it. 120 divided by 3.3 ohms. And what do we get for the total? You can probably round it a little bit too, as you'll need to when you get there. Got a couple folks here have it. Let's see if anybody else. I know there's a lag. Thanks for punching it out, folks at home. Okay, Joe, what'd you get?
36.4.
36.4. Does that check over here with mounted? Okay. Let's see if folks at home got the same number. They're still punching. What's the label? Either folks at home or folks here. 2 people know, 3 people know. What's the label going to be? How about Lauren? Amps, right. That's a lot of amps, isn't it? Whew, that's really a lot. Don't put your finger on that. And 36.4, Alessia had that, as did Tim. Good, thank you so much. Good. Beautiful. Last question. And this is very different than a series. Find the current in each resistor. Ooh, that we haven't done, but we can do it. Okay, so I'm going to grab the formula here from that Linus gave me a moment ago. It's V over R. But you know what? I'm going to say, you know what? I want it for resistor number 1 first. So I'm going to call it I1. The voltage is the same everywhere here, but I'm going to put it over R1. And I'm going to put this next to it because I don't want to run out of room because I got folks at home doing this. Okay, who's sort of followed here? So what do I put? Timothy P, what do I put here for the numbers?
You put 120 volts over 8.
You got it, 8 amps. So you grab that from the first resistor. And let's find out what that is. Erase a little bit over here. Amps, exactly. Thank you. That's good. So, what is that? 120 divided by 8. It's going to be, again, some big number of amps. What'd you get for me, Linus? 15? Good. Let's find the other two, okay? So next one, V over R2 to get I2. And the last one, you can kind of run ahead of me and figure this out, right? Last one is I3. It's V over R3. Yes, I'm writing small because I'm running out of room, aren't I? And I'll go ahead and do this. I think you get the idea. So R2 is what, 10 volts. Oh, that we can do in our head, can't we? 10 ohms. The last one, 120 volts over 12 ohms. We can do both those in our heads. I picked some good numbers. I think like that small. Okay, so sorry to squeeze this in so small. So 120 divided by 10, everybody. 12, 12. Oh man, that's the wrong label out there. Look at that. I'm getting sloppy. You guys said amps and I wrote ohms. So 12 amps. And 120 divided by 12? Yeah. Good. Can you do me a favor? Add these all up just for fun. 15 plus 12. 15 plus 12. 27 plus 10. 37. Is that pretty close to what we got for the total? Ah. If you get pretty close, within like 5%, it's from rounding. Okay, it's not a big deal. then you've done it right. Why does that make sense? In your own words, why does that make sense? Emily, why's it gotta work like that and add up to that?
Because, parallel, come to out to the full circuit.
Yeah, you got it, because it's coming from how many pathways up here? 3, and then they add up together again. Good. Thank you very much. Perfect. Take a break here. Take a break, folks at home. We'll continue in about 7 minutes. I got some lunch here. Any other Bible books you like to read? You could give him your books. You're welcome. I know I can find Mr. Lee. You guys gonna miss that? What's the workshop? Somebody
Oh.
Like, seriously. Yeah, okay, one time. Well, let's say check.
I had your sister.
None of my sisters teachers have ever done that.
Anyone else? There's only one. You're lucky on the first floor. I have a tendency to throw Okay, so here we go, folks. It's your turn, so I'm gonna erase this. And I'm gonna have you guys solve one completely. So use what we just did. And please give me formulas too, like we do in physics, so I can see how you're doing it. So let's make it again a circuit in Germany. So we'll say it's 220 volts. And like this. Doesn't really matter. There's another way to draw a parallel circuit. So let's just be 1, 2, 3. And we'll do 22 ohms, 10 ohms, and 40 ohms. For 3 resistors. Okay, so here we go. Folks at home, please try this as well. Here we go. First thing I'd like to do is find the total resistance. That's going to take a little work. And then I'm going to have somebody do this on the board. And we're going to do part B. Find the total current. That's pretty quick. IT. And then see here. Find current in each branch. Another way to say pathway, each branch, like a branch on a tree. Okay, so try that at home too. I'll come down here and help folks out. You find the total resistance, the total current, and the current in each resistor. That's supposed to be T. And we'll have some folks put those on the board a little bit. Set them all up. If you don't have your calculator, set them all up and you can still get it all ready, even if you can't get the right answer. Well, you can't get that answer because you don't have a calculator. But if you got your phone, you may use your phone and use the calculator on your phone, okay? I'll let you do that for this exercise. Okay, folks at home, once you get answers, you can punch them in, and later we can see if your answers were correct, okay? Uh-huh. How's it look? Yeah, yeah, that's kind of. And is that less than all three of them? Good sound. Everybody's looking pretty good. Call me over if you got a question. Yeah, remember it's one over. So you only have to flip them, you can do that. Yeah, you did, yeah. And then throw the right label on, but throw some other labels in it too, but, at least on an answer. And then I think that's right. Mhm. Mhm. Yeah, you come along too. Yeah, you're going good. Probably there, no problem. And for folks at home, if you can't read those, it's 22, 10, and 30 are your three resistors. Okay, folks at home, any answers to A, B, C? If so, you can type them in and we'll check them with you, okay? Your stuff looks great, but that's right. You don't want to give the numbers again, just check it out. Check it out once more. You need to just round it, so 5.2, and then 5. Okay, yeah, that's all right. Okay, all right. That's, I would just keep it. And if I had the answer to teacher why, basically all my numbers are about 2 numbers. So we would round this also to 2 numbers. That's kind of how it works. We'll talk about it next year. Okay. This is part 8. One, two, part 2. You got C down? Yeah, we do part C. Good. I'm gonna try and move this so folks can see that a little better. Okay, let's see what others get. Punch in and let's see if you got the same thing as Zach, folks, or not. That'd be great. Like the one, the formula, and then the numbers in it. Okay. You can put it over here if you want. We got thing to see. So we can see over here. That way folks at home can see too. All right, yeah, you may have to load this up on. When they're done, just grab a marker here. Folks in the audience, both Charlotte and Amelie are using good labeling, so check your labels to see if they're on the numbers as well. Okay, yeah, you can see it underneath there, minus that grade. Please read that. right. Thank you so much, everybody. Okay, I'm gonna read these folks at home in case you can't see them. Here we go. So we got from Charlotte this 1/RT plus 1/R1 plus 1/R2, 1/R3. She's put in the numbers for the three resistors and then got the decimals. So she got 0.175 for total is 1/RT. Then she flipped it, whoop, and got 5.7 ohms. And let's see. Yeah, that's close to what Zach had. Might just be a labeling difference. Okay. So 5.7 ohms. How many got that here in the classroom? Good. All right, 5.7. Okay. For the next part, we've got from Linus here. We got the voltage divided by the current. To be picky, Linus, because you know it's my job to be picky. Probably we'd say it's V over I. I know it's measured in ohms, but anyway. So V over I, and he's got 220 volts divided by 5.6. His value for it, round a little different, it's okay. So 39.28 amps, so we can just call it 39, that's fine. We can round that a little bit too. 39 amps. And I think somebody at home got that as well. Alessia, maybe you mean 39 amps, because that would be the current would be in amps. Okay. So that's the total current. Wait a minute. Arthur? Yeah, isn't it R? Okay. Why did I put that there? My mistake. Thank you. Okay, so V over R, pardon me, everybody. So then it's 220 volts, 5.6 ohms, or 5.7, and it's about 39 amps. Right. Oh. Part C from Amelie. Look at this nice, clear writing and nice labeling she's got. So for the first one, V over R1, 220 volts over 22 ohms, 10 amps. The second one, 220 volts over, 22 amps. First one, second one, 10 amps. And the third one, 220 volts over 30 amps. And here's her three answers. I'll read them for folks at home. 10 amps, 22 amps, 7.33 amps. Let's see if it adds up to the total that Linus got. So what do we got? We got 22 plus 7, 39 amps. Ta-da! Yeah. Questions from all of you. Parallel circuits are a little weird, but you've done pretty well. Okay, questions at home? How we doing? Okay. Part C. Yeah, part C would be 39. Let's see, it'd be 39 amps because it's the current. V over R equals I. That's the current. So it'd be 39 amps for A. Okay. Good. We got time. Let's go ahead and try a combination. There's a lot of actual circuits, especially in your handies, calculators, whatever, are combination circuits. So away we go. Questions at home before I erase this? Let's see. Everybody okay at home? Hope you can see that enough. People did nice clean work, so I think you can see that even in the video. Okay, so my question really is, what if it's a combo of series, oh man, come on, teacher, right, series and parallel. Okay, here's my hint. My hint is start small, work bigger. Okay, here we go. let's say we're in America, so we got 120 volts. And let's do this. And we're going to do this. And we're going to do this. Oh, sorry. I could make it more complicated, but I guess that's complicated enough. So notice I got a little what? Series and parallel. Man, it's crazy. Okay, so let's just put some numbers here. We'll do some easy numbers. 5 amps, or 5 ohms, 4 ohms, 8 ohms, 6 ohms. So look at my head. Start small and work bigger. What do you suppose I want to do first to get things sort of figured out? Which part might I want to do first with this combination circuit? Take a guess. Quantum.
If they use them, maybe it's one first, the, just add them together, maybe like that.
No, it's got to be the opposite, and we'll see why in a second. I got to do the parallel part first. It's sort of like this. And it's good, Malta, you recognize this as partly a series. Boom, boom. But the thing is, this could be totally a series if I could combine which ones. It could just be a series circuit if I could combine, Timothy? You gotta answer my question. Yeah. The 4 and 5. If I could combine those somehow, then I could make it totally a series circuit. I'm going to redraw it after we do this, so you'll see why I'm doing it this way. So we're going to do this parallel part first. Because it's the smallest part, not because it's parallel. Okay, so we're going to call this R parallel. But that's not right, is it? It's 1 over that, because we know the law. So R for the parallel part is 1 over that R equals, so just the parallel part. How can I get that then? How about Lauren? What can I put in? What's my parallel resistors?
4 ohms, 5 ohms,
All right, so 1 over,
4 ohms,
all right,
plus 1 over 5 ohms.
there you go. All right, good. So let's do that. So 1 over our parallel, I'll say P here. We know some of that. 1 divided by 4. Michael, what decimal is that? You know that one?
0.3.
No, close. 1 divided by 4 is what decimal, Lauren? You got it. 1 divided by 5, somebody? 1 divided by 5 is multiple what?
Is it 0.2?
Yeah. So check this out. We got then 1 over the RP equals 0.45. And then we got to do what? The button that a lot of you did, the x to the minus 1 button. Flip that sucker. So the parallel part is 1 over that. So what is it? I'll write it because I don't want to lose anybody. 1 over 0.45 equals 2 something, right? 2 point something. Let's get Kiara.
22,
And what label, Kiara, will it have there?
ohms.
Ohms. I'm gonna help you by rewriting this. Rewrite your circuit. You don't have to do this, but it often helps students go, oh, that's why we did that, okay? So here we go. Here's my voltage at the top. And now it's like this. Now I got the equivalent of the parallel part is 2.2. So now this has become this. Over here, this is still 8. And this one is still 6 ohms. And that's still 120 at the top, 120 volts. See what I'm saying? So it's a way of looking at it and simplifying the circuit. Oh, and now it's just like a series circuit. Because I took the parallel part and squeezed them together and made them a little series bit out of it. Let's see if I got any questions. I know that's tricky, folks at home. Not yet, but we'll see if they got a question about it. So now, okay, how do I get, once we've done that, I get the total resistance by doing what? What do I got to do with what's left? Honest? Add all of them. Good. So I'm going to not put the formula this time because I run out of room. Put the 6 plus the 8 ohms plus the 2.2 ohms. Oh, we can do that in our head, right? 6 plus 8 is? Good morning. 6 plus 8 is? 14 plus 2.2? Good. Label on the final thing, folks. Ohms. Good. And then the rest of it, okay, you can find the total current. I'm not worried about that at this point. But let's just talk about this. Or did I screw up? Didn't I write that? No, because I'm thinking about the next thing. Thank you. Man, it's hard to get good teachers anymore, huh? Okay, 16.2, thank you. Exactly, add the remaining together. Right, exactly. So 16.2 ohms, 16.2, hopefully folks at home got the same thing. Question, Kiara?
Can you always combine them like that?
Yeah. I'm going to give you a different one to try right now, so you can kind of test yourself and see. Okay, here we go. Let's go back to Europe, 220 volts. I'll make it extra tricky. Just so you got a challenge. Don't want you to get bored, but I'll make the numbers easy. So let's make this 4 ohms. We'll make this 3 ohms and 3 ohms. We'll make that 8 ohms. And what I want you to do is for A, find the total resistance. And then for B, find the total current. But B is pretty easy. A is the hard part, isn't it? Okay, so can you do it? Let's find out. So I'll give you a little time to think about it. Start small and work big. And I'll come around and help you out. Folks at home can try that as well. And we'll do that together in a couple of minutes. Again, the numbers at home, 4 ohms, 3, 3, and 8. Any other Corona garbage before I put it out in the hall? And if you really like this stuff, folks at home and here, you might consider being an electrical engineer. You sure got a great job, and it's always in really high demand, and they deal with lots and lots of circuits like this. Well, there's several things first. Yeah, there's several things first. Listen, now, there's something. There's something first. First, there's something that goes first. Yeah, but that's not the right law. These two are on the same line, so that would be like a human circuit. Not one over, it's just what? Yeah. Yeah, just add them. Let's see what you do. Oh, so you just add them. Yeah, right. Good. Chabon. What? Oh, no, it's like the oh, you're working really hard. All right. I thought you were doing, okay, you can just add these two. Is that what you did? 8 and 6. That is 6. 8 and 4. Not all 2. 4. Right? Okay. You're making it too hard. Yours would be really hard that way. Okay, not going to do. Yeah, you can do that way, essentially. You're adding them, right? So you 1 over 6, right?
Yeah.
And did you have a 4 in there too? So 1 over 6 plus 1 over 8 plus 1 over 4.
Oh.
So you got to put that down. Right. No, you're making this too hard. It's not, this part's not fair. Just because every time you get first, you want to do these two together. Yeah, it's like a real time series. So do that again. There's my hint for folks at home. My hint to you. Let's see, so once you have those copies, now you can double search that. Then it's going to be parallel. We want to do all three branches. 4, 1 over 4, 1 over 6, 1 over 8. I'll keep it 1 over 3. Do all three branches together. Because if you separate it, it's probably not going to work out. So, just for folks at home, because I can't see them and I want to be able to help them, what did I tell a lot of you? What could you do with this part, the series part? I could just do what, Lauren? Add. So let's just show that to folks at home. Do that first. 3 plus 3 equals 6 ohms. And then I redrew it down below, okay? All right. Shall we do this part now? So what's the part down below? It's now a circuit. It's now a circuit. Parallel circuit. So give me the formula parallel again, Charlotte. What do I got to do? 1 over RT is going to equal.
Well, which numbers you just,
How about formula first?
1 over,
1.
it's,
Yeah, just the rest of 1 over R1 plus 1 over 1 over R3, right? Okay, now go ahead and continue. Charlotte, drop me some numbers in.
1 over 6, plus 1 over 8.
Plus 1 over. We got 3 branches, folks. Branches? 4. 6, 8, and 4. I know they look far apart, but they're still just one parallel circuit. Okay, so folks at home, we changed it. So part of it was a little bitty series, cute little series, and this one is now a actual regular parallel. 1, 2, 3 parallel lines. I could have squeezed them closer together, but it doesn't really matter. Good. Let's solve that. I'm going to go right to the chase. Those who solved it, no, I won't go to the chase. I don't want to lose it. 1 over 6 is what? 0.116 or 17, we said. And 1 over 8, we had that already today, 0.125. And 1 over 4, we had that already, that's 0.25. Okay, so okay, so what'd somebody get here? 0.1. Just so I 0.535. Got to check with everybody? Yeah, okay. 535. Good. And then finally, because I'm running out of room, flip it, and the RT is what? What did we get then? Timothy? 1.8, that's around 1.9 if it's 5 after that?
That's 1.8.
4.5, okay, so 1.8, others get the same? 1.9 rather? Okay. And 1.9 ohms, is that right? And that's less than all three, which makes sense. So folks at home, if you can see that 1.9 ohms, and then Part B. Whew. How do I find the I again? How do I find that part again? What do I gotta do? Lauren?
IT is equal to D over R.
Good, continue, Lauren, and plug in some numbers for me.
IT is equal to 220 volts over 1.883, 1.890.
890, okay, so however you wanna do it, I'll do 1.9, just because I did that over there, but that's fine, there, Lauren, okay. And what'd you get?
I have to recalculate it because my number was wrong before.
Okay, all right, so everybody else, let's see what we got, Malta,
Like 38, 39.
39.
Um,
Let's see if others at home got the same thing. 39 amps, does that check with folks at home? Hope so. Okay. That looks about right to me. I think that's right, Alessia. I think it's 1.9. Is that what folks here got for this total, 1.9?
1.86.
Okay, so rounded 1.9. Okay, so, but it's about the same thing. Yeah,
I just have a question.
Yeah.
So how do we know when it's the further or the combo?
if it looks really hideous, it's probably a combination. If it's parallel, just look for parallel lines. So even though these were far apart, PR, there's still just 3 parallel lines.
Yeah, but we have to check it. We did an example with also the parallel lines and then it wasn't parallel.
Well, but one of those we had 2 parallel lines, and then we had a couple others that were just along a single line. Like, I think we had this, didn't we? And then we had one like here and one here, and then these. So we had to do the parallel part first. And then we had to add in these puppies for the series part. Part of this, to be honest, Kiara, is experience. It's just experience. But my overall idea, start little, work big, that's what I want us to try. Okay, let's try one more. And all we're going to do is find the resistance. I'll try and make the numbers easy. Okay. Okay, so. Yeah, I could make it more complicated, but I think I won't. That's I think enough. Okay, I tried to make the numbers easy so we could do it fairly quickly. I got 3, 3, 3, and 10. So folks at home, 3, 3, 3, and 10. Start little, work big. So think of what to do. I think we got just enough time to solve this sucker. Yes, Tim. Yes, Tim. Good. Tim H has it. Let's see if some folks here got it. Our young electricians. Yes, yes, good. Yeah. Yeah. This is my antenna, right? Yeah, but it's one of them.
Yeah.
Good. Let's do it good.
No.
Yeah, exactly. Exactly. I think so essentially, and from Tim Hartling and others here in the classroom, these add up and I just become 9 ohms, don't I? And then from there on, it's just a circuit. It's just a parallel circuit. I'll let you solve it. Thank you. Good job today. Thanks everybody at home. I'll put this online so folks can see it who missed the first part. Bye.